Now let's get into the another technique of data transformation, which is log transformation. So if you want to understand the log transformation, you need to know what is a normal distribution and what is a logarithm. So let's begin with what is a normal distribution. Before we get into log transformation, let's quickly talk about normal distribution. Normal distribution is a probability and statistical concept widely used in scientific studies for its many benefits. Just to name a few of these benefits, normal distribution is simple. Its mean, median, mode have the same value, and it can be defined with just two parameters, that's a mean and variance. It also has important mathematical implications such as the central limit theorem. And you can see that on the screen, mean, median, mode, and it's symmetrical about mean, median, mode, and at the end you have asymptotic tail. So unfortunately, our real life data sets do not always follow the normal distribution. They are often so skewed, making the results of our statistical analysis invalid. That's where log transformation comes in. I'm repeating again, our real life data sets do not always follow the normal distribution. They are often so skewed, making the results of our statistical analysis invalid. That's where log transformation comes into the picture. So, then what is a logarithm? Logarithms are essential tools in statistical modeling and statistical analysis. A logarithm can be defined with respect to a base b. So this is how it looks. A logarithm can be defined with respect to a base b, where the base b logarithm of x is equal to y, because x equals to the b to the power of y. X equals to the b to the power of y. So you can take any positive number as the base of the logarithm, but most commonly used are base 2 and base 10 and a natural log. So the natural log is the base of the natural log is the mathematical constant. That's nothing but e, that's Euler's number, which is equal to 2.718282. So the natural log of 7.389 is 2, because e square is equals to 7.389. Anyway, we'll be looking into that. Let's take some examples to understand these logarithms very in a better way. So log transformation. Okay, so what I'm saying is, you know, log, just log of some x is equal to y, correct? Now, so the value of the value of y depends upon the base. So if the base, now what will be the x is depends upon the base also. Okay, so that's where you have to put the base here. So base of x, this is the correct equation. Now you can convert this if you want to have the x value. So x is equals to base to the power of y. That's what I'm saying. Okay, now let's take one example. We have three bases. You have base 2, base 10, widely used one, and base e, which is nothing but 2.7188282 Euler number. So this is called a natural log. Okay, so now what I'm going to do is I'm going to import math. So math.log. So I'll take the base 2 first. Log base 2 of, how much I want, 8. So what would be the value? 8. So obviously 2 cube is equal to 8, correct? And here is the value, 3. So now let me do one more value. So you guess now. So I want log base 2 of 16. 16. So before I calculate this value, I'm gonna give, so you can calculate. So what will be the answer? It's 2 power how much would be equal to 16? That's what the question. It's 4. So 2 square root of 16. Okay, that's pretty simple. Next, math dot log 10 this time. 10. So I want to go for the 100. Then what would be the answer for this? It's simple. 10th root of 100. How much? It's 2. That's it. It's 2. So whenever you see a log with the base of something, the value, it's simply in another way you can convert that into, let me show it here. Okay, here when you say log base 2 of 8 means you can simply say 2 and then square root of 8. Of course this is directly square root of 8 and this is directly square root of 8. But when it comes to this with the base 10, 10th root of 100, obviously you'll get the value 2. So that's how you convert. I know that's how you calculate the value. So log of base 2 of 8 is equal to 3 and log of base 2 of 16 is equals to 4 and log of base 10 of 100 is equals to 2. So the base is also very important. It's nothing but the squaring. It's nothing but the root of something. That's what at the end of the day we are calculating. So now let us do one more thing. So the math dot log of, natural log I'm taking. I will give a value of 7.839. 7.839. But before that, let's calculate the square root of, the natural log is given here. It's 2.7. Yes, and it's 7.389. It's a close of the value. So let me execute and see, and you got the 2.05, close to that. It's a close to that. That's what. So the natural log also has a base that's close to 2.71. Okay, that's what the natural log base, and it's again 2.7 root of the value which is inside. That's how you get the value of logarithmic. Okay, I hope this one is pretty clear for you. So we have seen what is normal distribution and we have seen what is a logarithm. Now it's time to get into the what is a log transformation. Log transformation is a data transformation method in which it replaces each variable x with a log of x. A log transformation is a data transformation method in which it replaces each variable x with a log of x. So the choice of logarithm base is usually left up to the analyst and it would depend on the purposes of statistical modeling. Of course, it's up to the statisticians to decide what base you would go with. We have base 2, base 10, and a natural base which is 2.78. It's all up to you to decide. Now, when our original continuous data do not follow the bell curve, we can log transform this data to make it as normal as possible so that the statistical analysis results from the data becomes more valid. In other words, the log transformation reduces or removes the skewness of our original data. The important caveat here is that the original data has to follow or approximately follow a log normal distribution. Otherwise, the log transformation won't work. The important caveat has to be remembered is the data has to follow the original data, whichever you want to do the log transformation, that has to follow approximately a log normal distribution like this. Otherwise, log transformation won't work as you see on the screen. Okay, remember that caveat. Okay, so before the log transformation, this is the log distribution data, and after the log transformation. Okay, so now let's take one example. Simple, if you want to see just simple conversion of log of data to the logs, it's very simple. So let's take import numpy as np, and x is equal to, take 1 comma 2 comma 3 comma 4 comma 5, and y is equal to np dot log of natural log. Let's take natural log, sorry, log of x, and this is what is your y. So this is what is our array. So now let's take an example. No, like the concrete example for this. So let's create a sample data frame to understand this, so that we can have a better. Let's create a sample data frame with exponential data. So df is equal to pd dot data frame, and yeah, okay, we're going with the logarithmic 100 and 1000. This is what is our data, the first one. The second one is b 0.1. I think we'll be going with base 10. Of course, by looking at the data, we can make out that we'll be going with the base 10 and 100. So that's it. Our data is ready, data frame. So now let's perform log transformation on columns A and B. So log transformed data frame is equal to np dot log of df. So let me print log transformed data. Here is your log transformed data. These are the values and these are log transformed.